Welcome to Chapter 4, Vodcast number 2. We'll be going through some practice problems for force diagrams. Question 1. A car with mass 1,500 kilograms is parked in the street. Write the equation which describes the forces which act on the car in the x direction. If I draw a force diagram for this car, I can see that the weight of the car is 1,500 kilograms times 10, or approximately 15,000 newtons. And the normal force would be equal and opposite to that at 15,000 newtons. And there are no forces in the x direction. So there is no equation to write because there are no horizontal forces. In the y direction, however, I can say that Fn plus Fg is equal to 0. And what I'm going to do is I'm going to look at my forces in the cardinal directions, that's straight up and straight down. And I'm going to call Fn positive going up and Fg negative going down. So Fn is 15,000 newtons. Fg is negative 15,000 newtons. And the sum of those forces is 0. And sum of the forces on that car is 0. The car with a mass of 1,500 kilograms is stuck in a snowdrift. Ruby pushes on the car with a force of 100 newtons at 0 degrees, but the car doesn't budge. So let's redraw the picture. Same car, Fg, negative 15,000 newtons, normal force. It's positive 15,000 newtons. And now we've got two sideways forces, which are much smaller than the weight of the car. We've got an applied force of 100 newtons, and then we've got a frictional force, which is also 100 newtons. And the frictional force, since the way I've drawn it is to the left, I'm going to call that a negative value. So now the equation which describes the forces which act on the car in the x direction, I've got the applied force plus the force of friction must equal 0. Or 100 newtons plus negative 100 newtons equals 0 newtons. Write the equation which describes the forces which act in the y direction. This is exactly the same as question 1. Fg plus Fn equals 0, or I can say that negative 15,000 newtons plus 15,000 newtons, oops, forgot my n, equals 0 newtons. Question 3. Write the equation which describes the forces which act in the x direction. Okay, before I do that, I'm going to think about my force diagram for this object, which is suspended. So here I have a 100 Newton object. That's the weight. Fg is 100 newtons. Then we have a tension force up at an angle here. This cable provides tension. I'll call that Ft. And then I'll call that Ft1 because I have another tension force going to the right, Ft2. I know that Fg is negative 100 newtons. And what I'm going to end up doing in this problem is resolving Ft1 into components. The horizontal component will be Ft1 times the cosine of my angle. Now I'm in the second quadrant, so my angle is not 25 degrees, but it's 25 plus 90, or 115 degrees. And then my vertical component will be Ft1 sine 115. So the forces which act in the x direction will be Ft1 times the cosine of 115 plus Ft2. And those two must sum to 0. B, write the equation which describes the forces which act in the y direction. Well, now I'm going to look at the vertical components. Before, in the last problem, I looked at the horizontal components, and I noticed that they are equal and opposite. And now I'm going to look at the vertical components, which I'm drawing in green here, and those must be equal and opposite. which means that FG plus FT1 times the sine of 115 must be equal to 0 newtons. Now I can use this equation to solve part C, find the tension in the two cables. I know that FG is negative 100 newtons. Oops. I don't know FT1. But I can solve it. I can add 100 to both sides. Now I can divide both sides by the sine of 115. Get 110 newtons. Now if I take this and I put it back into my first equation, I have FT1. I can say that FT1 cosine 115 plus FT2 equals 0. Well, FT1 is 110. Oops. And now I can solve for 110 cosine 115, which is 46.6, actually negative 46.6, which means that FT2 must be equal to 46.6 newtons. Let's keep going. Write the equation which describes the forces which act in the x direction. Well, this problem is essentially identical to the last one, except that instead of knowing FG, we know FT2. We know that FT2 is equal to 100 newtons. So, I can write the equation, it's the same equation in the x direction, same equation in the y direction. And to find the weight of the box, what I'm going to do is take my first equation and plug in 100. And I'm going to solve for FT1. I get 236.6. And then I'll go to my second equation to solve for FG. I get 214.4. Example 5. A wagon with weight of 500 newtons sits in a garage. Sam tries to pull the wagon with a force of 150 newtons at an angle of 45 degrees above the horizontal. The wagon won't budge. Draw a force diagram for the wagon. Okay, so I'm going to start out with my wagon, which I'll represent with a rectangle. I've got force of gravity, 500 newtons, or negative 500 to indicate that it's down. Then we've got Sam pulling with an applied force of 150 newtons, and that angle is 45 degrees. So what happens here is FA has components. The horizontal component, this is a 45, 45, 90 triangle. So to find the horizontal and vertical components, I would divide by the square root of 2. So FAX is going to be equal to 150 divided by the square root of 2, which is equal to 75 times the square root of 2. And that's the same thing as FAY. So what happens is that value is going to decrease the value of the normal force. The normal force doesn't need to be a full 500 newtons. It can be a little bit less. It's actually going to be 500 newtons minus 75 times the square root of 2 newtons. That's our normal force. And then there must be a friction force. There must be a friction force that is pulling back on the wagon that's equal to FAX. And that friction force must be equal to FAY, which is also 75 times the square root of 2. One more example. A brick with a weight of 10 newtons sits on an incline of 30 degrees. The brick does not slide down the incline because friction holds it in place. Draw a force diagram for the brick. There's my incline, 30 degrees. Here's the brick. Force of gravity. Parallel and perpendicular components. Normal force. Normal force must be equal and opposite to the perpendicular force. And then we have one more force. We must have a force of friction. And that friction force must balance out the parallel force. I can calculate all of these values. I know that Fg is equal to 10 newtons. I know that F perpendicular is equal to Fg cosine theta, or 10 times the cosine 30, which is basically going to give me 5 times the square root of 3. And the parallel is going to be equal to Fg sine theta, which is just going to be 5 newtons. And then we can see our equal components. We can see that the parallel force will be equal and opposite to the force of friction at 5 newtons, and the normal force will be equal to 5 times the square root of 3 newtons. And we will pause there.